So, since last week we are discussing the operation of the circuits which were earlier resistive circuits, for which we were applying the DC source, that is the constant voltage source and constant current source. Then later on we introduced ourselves with some kind of source which generates a voltage across it which varies in a particular manner as a function of time. That is in sinusoidal manner. Sinusoidal or co-sinusoidal, both are same. It depends upon from what point of time we look at. So we consider it to be sine of the V is equal to something sine omega t or something cos omega t. So we were discussing what would be the behavior of the circuit if such changing signal is applied. Obviously, if the signal is applied to a network consisting of resistances only, then there will not be any change, because it is a very simple circuit, because for resistor we do have a linear relationship between voltage and current. Or supply is gone. But for reactive components, that is inductor and capacitor, which exhibit a linear relationship between voltage and current, not in their direct form, but linear relationship of one with the time differential of the another, right? And in that context, what we find is that what will the behavior of the circuit needs to be analyzed. Then you will come to know about all these details as things progress. But sinusoidal signal has a peculiarity in the sense that it is called as analytic signal. Analytic signal means you may differentiate it or integrate it any number of times. You will find that the resultant is a sinusoidal wave of same frequency. Only thing, it will differ in amplitude and phase, but its shape will not change. That is not the case with other types of signals. We had considered one signal in some other context, that was, I had already stated that was to be listened, if understood, to be taken further, if not understood, to be ignored. Means we had one logic of e raised to st. That was just to unfold you the things. We are, see, these are some issues of which if a classical approach is adopted, hardly anybody understands. I had gone through such phase wherein one doesn't understand what is for impedance, what is the role of Z. You might have come across that I hope everybody knows impedance of inductor is J omega L, right? You must have heard. Impedance of capacitor is 1 upon J omega C. Then the moment at which the letter Z comes, we get another pseudo understanding of something imaginary. So what do we mean by impedance to be imaginary? In what way it makes sense? These are very difficult things to be understood in the classical context. Therefore, in learning process, not only the things which are to be learnt, but the sequence of the things in which those should be exposed to the students is also important, because the same content can be made to understand very easily if unfolded in a proper sequence, and if it is unfolded in another sequence, even though the total content being same, none of them is understood. So we are trying our level best to see that it is understood by a majority. So sine and cosine, or sinusoidal, I am more particular and broader, not sine and cosine. A sinusoidal waveform is of a typical type wherein even if it is differentiated or integrated, what we find is that its shape doesn't change, its amplitude and phase may change, and it is possible for us to write it in some form. So, one very important point which needs to be remembered is that in a network which consists of resistors, inductors and capacitors, whenever we apply one sinusoidal waveform as input to it, then voltage at any point, then voltage at any node or current through any path is always a sinusoidal waveform of same frequency. What it may differ is in amplitude and phase. Therefore, as we had written that the concept of, we could write impedance if voltage was e raised to st, but we did not understand it very neatly. But when voltage is of the form a e raised to st, we could write the impedance. Why? Because for a form of a e raised to st, its differential is s into the function itself. Whereas for sinusoidal now, even though there is no such scaling relationship, but I can write the relationship of differentiation in some simpler form. What I want to get rid of the d by dt term. Therefore, so last time some work was assigned to you for LC circuit. L was there and C was there. Have you finished that? Have you gone through the video lectures? Did you get the video lectures first?
Yes.
Since few have got it and few have not got it, it is very simple for them that they should get it from those who have got it. So, based on this, we would like to go a step further. If I have a voltage source V T is equal to A cos omega t. Vt is A cos, or I write first, this is sine. A sin omega t is the voltage source that I am connecting to a capacitor. Of, say, capacitance C. What will be the current? I will draw a bigger figure because it is not well captured in the recording. I can use Vp as a P as a subscript. Vp sin omega t is the input, is the voltage source, and this I am connecting to a capacitor of value C, and we want, this is Vt, so this is I. So what would be I? I think now, since it is C dV by dt, it would be C d by dt of it. I can rewrite it in simple form. Omega C Vt cos omega t. Omega C Vt cos omega t. So Vt and It, I can look towards the relationship in a particular form, in a form in which the representation should be simpler. So what I find now that both are sinusoidal signals of same frequency. And their amplitudes differ by a factor of omega c. Now, the resistance of a resistor was defined as V upon I. Resistance of a resistor was defined as V upon I, and we have been very much familiar that V upon I is always equal to R. V upon I is always equal to R, because for resistor always whatever may be the circuit conditions, Vt must be equal to R into It. So the ratio is always R. Vt upon It, the ratio is always R. The ratio is always R. In the same context then, what would be if we take the ratio? If we take the ratio, what will be getting? So, we will elaborate it in such a manner that the concept of impedance should be quite clear to you. Impedance of capacitor, impedance of inductor, impedance of a mixed circuit. Everything should be quite clear, beyond doubt. We are trying our level best. I am trying my level best to teach. What you learn can be a question of discussion. If we find that despite every attempt to teach in a simple manner, if learning is difficult, then we have to find out the solution collectively for the problem. Because it would be a very severe problem. That despite every attempt to simplify the things in teaching, if learning is not simple, it's of no use. The classroom discussion becomes completely irrelevant if it is not useful for the students. Simply because it is a good oratory and it is classically correct. It is not an elocution contest. Teaching is not an elocution contest. Even if it may be to some extent wrong or imperfect, but if at the level of students to whom it is required, and if that is satisfying the needs in that form, that is better teaching. So if we take a ratio of this, then what will be the ratio straight away? Ratio would be 1 upon omega c tan omega t. Have you ever asked this question to yourself? That why impedance of capacitor is not said to be 1 upon omega c tan omega t? Because Vt upon It, what is going to happen then? There would be a phase difference of 90. If you plot waveforms below each other, you will find that at some points there would be zero voltage but current will flow. At some points there will be zero current but voltage will be there, and the ratio tan omega t will have its value ranging from 0 till infinity. So impedance, instantaneous impedance, if we talk in that terms, or if we talk about the ratio of instantaneous voltage and current, it would be varying largely from 0 to infinity. And I am not interested in that. By impedance, by expressing a figure of ratio, I want that it should give me a good information instantly by a single value. Tan omega t itself is not a single value. Tan omega t is a function of time, and in which I am not interested. I am interested in taking a ratio for the purpose that I should get a good idea about the relationship between Vt and It. How I am interested in knowing how Vt and It are related to each other. The answer to the question of this relationship should be given in such a manner that the problem is solved. Otherwise, you might have come across many people. If there is some problem, if you go to a person with some problem, then depending upon upon the person's mindset, attitude, background and many other factors, you will find one class of persons who will very classically analyze your problem and indicate to you how severe it is. Have you gone with to that person to analyze the problem and come with a perception that it is quite severe? No. So you have approached to him with a problem expecting a solution for it. So good analysis and very, what we can say, artistic description of the problem is not expected from problem solver. What is expected is solution to that problem. So the impedance is a definition with a purpose that it should give you the exact nature of relationship between voltage and current, it is good analysis of the problem, tan omega t, so that the ratio can be 0, ratio can be 1, ratio can be infinity. It can have a very wide ratio, and that too again from minus infinity to plus infinity. So this is not what is expected, right? So what we should try, again as I had already stated, there are many ways with which one can look at the problem. Similarly, there are many ways with which I can look at the relationship. I do not want this ratio in this form. So what I do, I decide to have this ratio in the form of phase shift. I would like to express the ratio in the form of phase shift. So what is the phase shift now? 90 degrees. The phase shift is 90 degrees, right? What is the amplitude ratio? So the relationship between voltage and current across a capacitor for sinusoidal nature of voltage is to be expressed in the form of ratio of magnitudes and the phase shift amongst them. So this relationship is now expressed, or it cannot be expressed by a single value. As regards to resistor, what was the case? It was expressed by a single value because for which the question of phase shift has not come. Why it has not come? Because it is exhibiting a linear relationship between V and I. Therefore, till this point of time, the relationship was expressed by simply the ratio, and the ratio was always constant and was expressed by a single figure. But now, since we are having with us the components which exhibit a linear relationship between voltage and differential of current or vice versa, what we find is that everywhere at any point or across any path, the voltage and current would be sinusoidal, but it would be having different amplitudes and different phases. So if ever you are asked to express the relationship of two sinusoids of same frequency, you cannot express it by single value. Why? Because we can very easily write down that I have one signal of A1 sine omega t plus phi 1, and second A2 sine omega t plus phi 2, right? So now if these two signals are to be compared, if we want to find out relationship between these two signals, what will express the relationship? What will express the relationship? It is what is the ratio of amplitudes and what is the difference in phase. So A1 upon A2 and phi 1 minus phi 2. These two figures define the relationship. These two figures define, or if we take ratio of amplitudes and it is coupled with the difference of phases. Only single value is not expressing the relationship completely. So is it clear? So the two sinusoids of same frequency can be compared with each other by taking ratio of amplitudes and difference of phases. Therefore, impedance, when we say Vt upon It, that time it is presumed that for whenever we take ratio of amplitudes, it is coupled with difference in phase. So what would be the ratio? I am not interested in tan omega t. So I can rewrite Vt as Vp sine omega t and It as omega c Vp cos omega t is
Sin omega t
cos omega t and sin omega. Can I write it as sine of
omega t minus omega 2
omega t
minus
plus or minus
by 2 minus omega t
plus 90 sine of omega t? Then what is the ratio? Ratio is 1 upon omega c and angle omega t means omega t plus 0 and angle minus 90. Is it clear? So it is 1 upon omega c angle minus 90. This is the impedance of the capacitor. So impedance is a parameter which is resistance like, means which is expressing the relationship between voltage upon current in a different form. It is not an instantaneous ratio. It is not an instantaneous ratio. It is the ratio which is explaining me the overall relationship between voltage and current. It is expressing me overall relationship, that is their amplitudes are, by looking at 1 upon omega c angle 90 minus 90, what I do get? I get an idea that voltage upon current, this ratio is such that the amplitude ratio is 1 upon omega c and phase difference is minus 90. Phase difference is minus 90. So this is called as impedance of the capacitor Xc. This impedance of the capacitor Xc. I would be deliberately avoiding the use of the letter Z. It is connected with something as imaginary. At an initial stage, we will derive everything without using Z. And then, at a proper stage, in order to simplify the things, we will introduce Z. So is it clear now? Impedance of the capacitor. Similarly, impedance of the inductor, what will be the case? Impedance of the inductor. Impedance of the inductor. For impedance of the inductor, you may derive it with this form also, but it is better that you apply current source. You apply a current source of IT is equal to IP sin omega t. So what would be VP? What would be VL? VL would be L di by dt. That is L into omega cos omega t. That is V. We can say VLT or VT. It is IT. So VT is equal to omega IP cos, omega LIP cos omega. And what is the ratio of voltage and current? That is equal to omega LIP sin of omega t plus 90. VT upon 90. The ratio is ratio of amplitudes is to be taken, that is omega L, and difference of phase, that is 90 minus 0. It is XL. It is impedance of inductor is omega L and angle 90. Impedance of capacitor omega C, 1 upon omega C and angle minus 90. And impedance of resistor is R and angle 0. Impedance of resistor is R and angle 0. With this, we can take up a simple task of we are finding out this, we have found out in a different way last time. That is how we have done it last time, by using putting equations we have done it. Now I am applying a voltage source Vt equal to dp sin omega t, that I am applying, and I am applying it across a series circuit of R and C. Now I am using R and C, not 1 and 1. What I want to find current. I want to find current. Now, since it is series circuit, impedances will add. Impedances will add. In a series circuit, impedances will add. So, what would be the overall impedance now between these 2 points?
R plus omega C.
R plus XC. Or to be more particular, it is R angle 0 plus 1 upon omega C angle 90. This must become
Minus 90. Minus 90.
minus 90. This must become A angle theta. This must become A angle theta. Any ratio, any relationship between voltage at across 2 points and current, voltage across between 2 points and current. So we can look at the effective impedance. So that ratio of 2 sinusoids of same frequency can always be expressed by ratio of their amplitudes and difference of their phases. So now you are supposed to calculate A angle theta. You have to calculate A and theta. So think, how can we proceed? r angle 0 plus 1 upon omega c angle minus 90. How they can add up?
A1 square plus A2
How
square plus 2
they can add up? In what way they add? Is it r plus 1 upon omega c and angle minus 90? In what way they add?
A1 square plus A2 square.
And angles?
Cos.
So just we want so what we want actually, we want A1 angle theta 1 plus A2 angle theta 2 would be equal to, will be equal to A angle theta. We want what is A and what is theta. A is equal to square root of A1 square plus A2 square. What is theta?
Inverse of theta 2 upon theta 1.
Tan inverse of
Theta 2 upon theta 1.
it is only connected to theta, two thetas, and not connected to A1 and A2 at all.
R2 tan theta 1 R1 plus.
That's all. What about theta?
A plus B sin theta. B cos theta 1 A plus B sin theta असं असते ना. B cos
What about theta?
A2 cos theta 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 रे उलट करताना असते त्याच्या इनवर्स असते याच्यात थीटा काढायचं अलग लक्षात थीटा एकच असते तिथं दोन थीटा आहेत रे त्यामुळे थीटा 2 पण थीटा 1 असेल मग हे कशात असते याच्या उलट करताना tan थीटा इज इक्वल टू असं असेल असं झालं मग आता आपल्याला थीटा करायचा ना tan इनवर्स असं असं कुठं सात असतं tan ते म्हणजे
What is the answer? Tan inverse of? That you don't answer now. You answer this. We are adding the two things, which is magnitude and angle.
under root A1 square plus A2 square.
What should be their effective sum? A1 plus A2 theta 2. Why should tan inverse? Why we are going for tan inverse here? So by common sense, it must be something. A1 theta 1 plus A2 theta 2. Something connected to this. This term must come. This term must come.
दोन प्रोसेसचा रिझल्ट कसा काढायचा असते दोन प्रोसेसचा रिझल्ट कसा काढायचा असतो अँगल थीटा 1 थीटा 2 माझा रिझल्ट मध्ये करायचा
If you want to take help of complex number theory you are aware of, you can take help of and give the answer. We need not spend time to completely find out the answer. Upon A1 plus A2, that's all. Like this.
सात 900 ना 7 200
What is A1 theta 1? It is ratio of two sinusoids. It is ratio of again two sinusoids. And we want, if we add these two, what we will be getting? We take a simple thing. We take in the denominator we take sin omega. Then we take sin omega t. It is amplitude is 1 and this is 0. Right? So first would be, let us say A1 sin omega t plus theta 1 plus A2 sin omega t plus theta 2. So this, if I rewrite it separately, it is A1 theta 1, A1 angle theta 1, A2 angle theta 2. If I add them, what I should get? So this you can rewrite. What this would be? A1 sin omega t plus theta 1 plus A2 sin omega t plus theta 2 can be written as A sin omega t plus theta. Because denominator is same, I have purposefully chosen the denominator to be sin omega t, for which the amplitude is 1 and phase shift is 0. So this A1 sin omega t plus theta 1 plus A2 sin omega t plus theta 2 can be expressed as A sin omega t plus theta. And what is A? What is theta? Is it correct also? As it is? Is it correct? It is also not correct as it is. It is not correct. So, what is the answer? A1 sin omega t plus theta 1 plus A2 sin omega t plus theta 2. What we get? It is not difficult. It is, even though somewhat tedious but not impossible. Sin of A plus B is what? Sin of A plus B is sin
cos sin
sin of A plus B. Sin of A plus B is sin A cos B
plus cos A sin
plus cos A sin. So it is sin omega t cos theta 1 plus cos omega t sin theta 1 plus A2 sin omega t cos theta 1 plus cos omega t sin theta 2. Then what will you do? You will collect sin terms and cos terms separately. So what we will be getting? For sin terms, one is A1 cos theta 1 and is A1 cos theta 1 plus A2 cos theta 2 sin omega t plus A1 sin theta 1 A1 sin theta 1 plus A2 sin theta 2 cos omega t. What we want, we have, since we are not the beginners, we know something trigonometry, so we know the form of the solution. What is the form of the solution? It is A sin omega t plus theta. What is this must be this being a sin omega t plus theta means what? A into bracket sin omega t cos theta plus cos omega t sin theta. Then what we have got for sin term? A cos theta sin omega t plus a sin theta cos omega t. If these two are to be equal, this must be equal to a cos theta and this must be equal to a sin theta. Right? If it is so, what would be a and theta? What will be the answer? What is A? What will happen then? What is A and theta? A equal to tan inverse of A equal to tan inverse of
square root of a1 square plus a2.
And what is A? One thing that since these are to be sin and cos, what we must have?
Cos of theta minus theta.
Squaring and adding. Squaring and adding must result to a square.
Square root of
This
a1
square plus this square is a square cos square theta plus a square sin square theta, that is equal to a square. So this square is a1 cos square theta 1 plus a1 square cos square theta 1 plus a2 square cos square theta 2 plus 2 a1 a2 cos theta 1 cos theta 2
sin theta.
plus a1 square sin square theta 1 plus a2 square cos square sin square theta 2 plus 2 a1 a2 sin theta 1 sin theta 2. That must be equal to
Square root of
a square. That must be equal to a square. So what it is then?
a is equal to square root of a1 square plus a2 square plus 5 sin cos of theta minus a2.
That is a1 square, because this is 1. That it means a1 square plus a2 square plus
a1 a2
2a1 a2
cos of
into bracket
cos
cos theta 1
of
cos
theta
theta 2 plus sin theta 1 sin theta 2 is a square.
cos of theta minus theta.
Is it right?
Cos of theta minus theta.
It is
cos of theta 1 minus
cos
theta
of
2. Theta 1 minus theta 2.
next. This
Under root.
entire is what?
Cos of theta 1 minus theta 2.
So a square is equal to a1 square plus a2 square plus 2a1 a2 cos of theta 1 minus theta 2. Is it correct? Sorry, cos of
दुसऱ्या दिवशीचे नंतर माझ्याकडे आणि याच्याकडचे कालच्या वाचन चव्हाण माझ्याच ह्याच्यात केलेलं माझ्या
so it will have two extreme cases. If theta 1 is equal to theta 2, if theta 1 is equal to theta 2, then a would be equal to a1 plus a2. Because for that time theta 1 minus theta will be 0, this will be 1, so it is completely a1 plus a2 bracket square. So a will become a1 plus a2. And if theta 1 and theta 2 differ by 90, if theta 1 and theta 2 differ by 90, in that case it would be this cos would be 0, so it would be a1 square plus a2 square square root. So two extreme cases would be there. One highest, that is a1 plus a2, and second lowest, that is under root of a1 square plus a2 square. And what about now theta? What about theta? If we take ratio now, if we take ratio of this upon this, theta is equal to tan inverse of this upon this. It is a1 sin theta 1 plus a2 sin theta 2 upon a1 cos theta 1 plus a2 cos theta 2. Can it be simplified further? So now the question was, what would be the IT? IT would be, we had this as VT, as VP sin omega t, and we want this as IT. So VT upon IT would be the ratio. This ratio would be impedance R angle 0 plus R angle 0 plus 1 upon omega c angle minus 90. So this is R and this is C. So we want to add these two. R angle 0 degrees plus 1 upon omega c angle 90 degrees. The addition becomes simpler. Minus 90 degrees. The addition becomes simpler because we are having very 0 on one side, 90 on the other side. So what is effective impedance? Effective impedance we want to find out. So that would be A angle theta. What is A? A is equal to this. A1 square R A square equal to R square plus 1 upon omega square C square plus, since the difference is 90, it would be, so A is equal to what is theta? Theta is tan inverse of A1 sin theta 1. R sin theta 1 is 0. A2 sin theta 2 minus 1 upon omega c upon A1 cos theta 1. It is R. A2 cos theta 2, that is 0. Is R. So it is equal to minus 1 upon omega RC, minus 1 upon omega RC. So what? Sorry, 10. Clear? So with this, you can rewrite the equation. Today we will continue at 2:15 and appropriate information has been given, so there will not be any confusion. Right? Today we will be holding the lecture for entire class at 2:15 p.m. It's alright? For the tutorial, it would be taking place on Friday at 3:30. Today's maths tutorial will take place on Friday at 3:30. Is it clear?